Is the following, if the following is true about triangle PMX, then find all the other angle measures. PMA is 68, so PMA 68 degrees, and MPA is 48. MPA is 48 degrees. And what I did to find PMX is PMX was already there, except I had to figure out this angle, which I knew was 90 degrees because of that 90-degree angle, so I had to subtract 68 from 90, so I did it. Which is 22. And then I did 48, and then M, which is 68, which is PMX would be, which would be 22, and then PMX would be, and then max, which is MAX would be that one, which, actually I'm going to do PAM first. PAM, and how I got that was I knew a triangle was 180 degrees, so 180 degrees, which is 180 minus 48 minus 68 would be 64. And then after that I had figured out that, so that was 64 degrees. And then what I did after that was max, which was MAX. And what I figured out was this was actually the same side as that, so it was supplementary. And I did, actually,
That one is supplementary.
Yeah. This one is supplementary, so I did 64 degrees.
That's vertical.
Vertical. It's vertical angles, and what I did was this is 180 degrees, so I subtracted that, and I did 100. I got 116, and I did vertical angle, and got 116 for that one. And now you have this circle, which should match up to 180 degrees. And then after that, I did 22, and then I got 180 for this triangle, which was 116 plus 22, and then I got the angle was 42 degrees. And then I knew this is a 90 degree if you did that. So then I did that and that, which I split the 90 like I did over here, and got 48 degrees. And then what I got for this was I split it into a right angle again, and then I ended up getting 42 degrees. And so I added those up to get 180 because this is a triangle if you look at it. And I got 68 degrees. So after that, let's add that up. MAX is 116 degrees, and AXM should be AXM would be 42 degrees, and AMX would be AMX, which would be 22. And that's how I got my answers.
Get one more shot.
Okay, so we're going to solve the third question in this, on the right of this little box here. So it says, if one side of an isosceles triangle measures 4 meters and the other side measures 6 meters, what could be the remaining side measure? Give all possible answers. So for those of you who don't know, an isosceles triangle is a triangle with at least 2 congruent sides. So that would be a triangle that may look like pretty much like this, or just any triangle with like 2 sides being the same. So I figured out that there are 2 ways that you can do this. First off, the number we are working with is 4 and 6. So that means we have 4 and 6 to work with right now. So what you do is that you set it up. So you draw an isosceles triangle. You write down like 4. You can first write down 4 as the base and 6 as the base. So you know that the 2 sides need to be exactly congruent. And if this one is shorter and these 2 are bigger, then you know that these 2 have to be the same. So what you do is you take the 6, and if these 2 are the same, you can just plug this 6 in right here. So this answer would be one of your first answers as 6, which would be the first answer since there's 2 sides and then they're equal. 6 is your first answer. Now since you have one more number, 4, you have another triangle. So this one, since 6 would be the base, since 4 was the base last time, it'll have a bigger base, so more kind of length. And then you could have shorter side length going to the tip like a pyramid. So this would be 6 and this would be 4. But since these 2 had to be the same, 4 would go over here. You could plug that in, and 4 would be your missing number. So the first one was 6, so you put the 6 there. You put a comma, and then 4 was your other one, so you put another 4 there, and that's how you solve the third question on the right.